Hello students, how are you? I hope you are well and safe, and I welcome all of you on this educational platform. In this unit, structure of atom, what we have discussed till now, we have discussed about the structure of atom via the Bohr model, Rutherford's model, cathode rays, anode rays, and de Broglie's hypothesis, Heisenberg's uncertainty principle. In this today's class, we will discuss a very important topic, that is quantum numbers. Students, what are the quantum numbers? In simple words, they are the address of electron. So how many type of quantum numbers, how they are determined, and what is the role of the quantum numbers? That we shall discuss in this class. So let's proceed. Quantum numbers.
So first let me tell you what exactly do we mean by quantum numbers. I'll give you one example. Suppose you go to any city to meet someone. In order to meet someone in any city, what you need? What you need is address. You cannot see someone, you cannot meet someone, you cannot visit someone if you don't have the address. In case of human beings, we need address in terms of what? In order to see someone, first thing that we need, suppose you go to any city, maybe Varanasi, maybe Ahmedabad, maybe Surat, or maybe any other city of India. Suppose you want to see any person in that city, first thing you need is the colony. You cannot see someone without knowing colony. When you reach to the colony, then the next thing you need is, what is the house number? The second thing you need is house number. Alright. Now suppose you have name of colony, you reach up to the colony, and then you reach up to the house, and then when you go there and you reach up to the house, you find out that basically it is a hostel and there are so many rooms in this house. So next thing you need is the room number. Next thing you need is the room number. And when you enter in the room, suppose now you get the value of room number and you reach up to the room number, and then when you enter in the room number, you see there are so many different person. Not exactly so many, or say for example you say there are two person with a similar clothes, with a similar size, similar weight, and similar face. So what next thing you need is the name. So in order to see someone, you need these four figures. Similarly, in order to locate any electron, first we need is the shell. That suppose you want to locate that in any atom where the electron is located, then you would be needing shell. After shell, you would be needing subshell. After subshell, you would be needing orbital. And in orbitals, there are two electrons rotating in the opposite spin, so you must have information of the spin. So these are the four set of quantum numbers you need to locate any electron. So what are the quantum numbers? These are the index numbers that are used to specify the position and the energy of the electron in an atom. Basically there are four quantum numbers, students. Number one is principal quantum number, represented by small n. The second one is azimuthal quantum number, represented by small l. Third one is the magnetic quantum number, represented by the m. And the fourth one is the spin quantum number, which is represented by s. So come, let us discuss various type of quantum numbers one after one. So here we go with the quantum numbers. First is the principal quantum number, students. This quantum number is denoted by small n, and it was proposed by the scientist Niels Bohr. What does it give to you? What are the possible values of n? So it can have any positive value which is whole number excluding 0, which means 1, 2, 3, 4, 5, 6, 7, 8 up to infinity. It cannot be in fraction. Now what does it determines? It determines the energy level. Please students, remember this one. It determines the shell in which the electron is present. If the value is 1, 2, 3, 4 and so on, then the shell is 𝕆𝕋𝔍𝑚𝑛. So you say if the principal quantum number is 1, I am talking about the first shell. If the principal quantum number is 5, I am talking about the fifth shell. So basically, whatever the value of principal quantum number, it gives you the value of shell, students. Now the value of n also used to calculate the maximum number of electrons that can be held into a shell. So how many electrons a shell can hold? This is also represented by this quantum number, and this is done by the using formula 2n square. Students, this is 2n square. Now say for example, someday you want to calculate how many maximum number of electrons we can accommodate in K shell. K mean first shell. So if the value of n is 1, I will apply this value here. It is 2 into 1 square, which is equals to 2. Now how many maximum electron you can accommodate in L shell? It is 2 into 2 square, which is 8. How many maximum electrons we can accommodate in M shell? Third shell. It is 2 into 3 square, that is 18. So these are the number of electrons, maximum number of electrons you can accommodate in given respective shell. These are the values. N is equals to 3 M shell, N is equals to 2 L shell, and N is equals to 1 K shell. So it is also very clear here that whenever the value of N increases, with the increase in the value of N, there will be increase in the size of orbital. So definitely an atom with principal quantum number value 3 is smaller, and the atom with the principal quantum number value 5 is larger. So with the increase in the value of N, energy also increases. Now the second quantum number, students, is azimuthal quantum number. You can understand this is the second line of address after reaching shell. Once you reach up to the shell, now next where we will go? Now we will go to the subshell. So students, it determines the angular momentum of the electron, and it is denoted by small l. And the value of L ranges from 0 to n-1, students. Very important. Its value ranges from 0 to n-1, where n is the principal quantum number. So yes, I can say that the value of azimuthal quantum number will always be smaller than principal quantum number. N is always larger than L. N is not equal to L. N is not smaller to L. In fact, N cannot be larger or equal to L. This is wrong. N can only be greater to L. That is only possible value. That is the only possibility. Principal quantum number is always greater than azimuthal quantum number. And the value of L, azimuthal quantum number, it gives the value of subshell in which electron belongs, and also the shape of the orbital, because orbitals have different shape. Now each shell consists of one or more subshells. Students, I believe that you already have information about the subshell. We have 4 subshells. There are total 4 subshells: S, P, D, and of course fourth one is F. There are 4 possible subshells which are used till date. There is another subshell which is G subshell, but the element discovered till date, we never required G subshell. Now each subshell is assigned an azimuthal quantum number value. Say if the subshell is S, its value of azimuthal quantum number will be 0. For P, it will be 1. For D subshell, it will be 2. And for F subshell, it will be 3. For G subshell, which is definitely not in use till date, the value of L will be 4. So these are the value of L for different subshells. If the subshell is S, let me tell you one more time, the value of L is 0, for P it is 1, for D it is 2, and for F it is 3. Now, you see this pyramid here, which is upside down. In this pyramid, I'll tell you about the values of N and what are the possible values of L. Now, suppose, say for example, N is 4. Say for example, the value of N is 4. When you say N is 4, what are the values of L can possible? 0, 1, 2, and 3. Because L is from 0 to N minus 1. Remember, the value of L is from 0 to N minus 1. So when N is 4, its value could be 0, 1, 2, 3. 0 means S, 1 P, 2 means D, and 3 means F. When N is 3, now the possible values of L could be 0, 1, and 2. That's it. Now it cannot be 3 because it will be equal to the N, which is not possible. L is always smaller than N. Azimuthal quantum number is always smaller to the principal. So if principal is 3, L cannot be 3. It will be 0, 1 or 2. It would be 0, 1 or 2. 0 means S, 1 means P, and 3 means D. So in the third shell you will see 3S, 3P and 3D. In the fourth shell you will see 4S. This is 4S, 4P, 4D and 4F. This is 3S, 3P and 3D. For N is equals to 2, the value of L could be 0 and 1. So this is 2S and 2P. For N is equals to 1, the value of L could be only 0. So this is 1S. This is only 1S. For first shell, only 1S is possible. These are the possible values of azimuthal quantum number. And one more thing. This word S, P, D and F, these words stands for sharp, P for principal, D for diffuse and F for fundamental. And these words have been taken from the astrophysics. So if the value of N is 1, the value of N is 1, then value of L could be only 0. And the subshell which is assigned for this value is 1S. Different subshells are designated by the first writing of the value of N followed by L, means NL. When I say 1S, this value 1 is L and this S is L, NL. Alright. Now if the value of N is 2, what are the possible values of L? 0 to N minus 1. 0 to N minus 1. So which is 0 and 1 lesser than 2. It will be equal to, when you say 0, it means principal quantum number is 2. So the shell is second and L is 0. So it is 2S. 2S. This is N. This is L. 2S. For N is equals to 2, value of L is also possible 1. For 1, it will be 2P. 2 is principal quantum number, P is azimuthal quantum number. Because L is equals to 1 means P orbital. So in the second shell, we have 2S and 2P. Similarly, in the third shell, if the value of N is 3, what are the possible values of L? Students, it is 0, 1 and 2. For 0, it will be 3S. For 1, it will be 3P. And for 2, it will be 3D. So these are the values 3S, 3P and 3D. Now, principal quantum number 4 means fourth shell. For the fourth shell, students, value of L is 0, 1, 2 and 3. The value 0 means 4S, 1 means 4P, 2 means 4D and 3 means 4F. 4S, 4P, 4D and 4F. 4S, 4P, 4D and 4F. Alright, so in the fourth shell, there are 4 subshells possible, S, P, D, F. And the azimuthal quantum number gives the energy which is associated with the angular momentum, J, which is MVR of the electron, and hence it determines its shape. This question examiner might ask you, what does azimuthal quantum number determines? And the answer is shape. Now The another quantum number, third one, which is magnetic quantum number. Students, magnetic quantum number represents the orbital. So this quantum number gives you the information of the number of orbitals. Students, please remember this. If I ask you in one line what magnetic quantum number represents, it is represented by small m. Let me tell you. It gives the number of orbital and their orientation. What do you mean by orientation? In simple words, you can see the direction in which they are oriented, and it is designated by a small m or ml, although most commonly it is designated by small m. It gives the information about the spatial orientation of the orbital in the space in 3 dimensions where they are oriented with respect to their coordinate axis. Now, these are the possible values of m. For any subshell, magnetic quantum number has how many values? 2l plus 1. So these are the total value of magnetic quantum number, 2l plus 1. These 2l plus 1 are the total values of magnetic quantum number. Now, for a given value of L, n can have value from minus L to plus L. Listen students, what you heard in the previous slide, 2L plus 1 are the total values. So the total values could be 2L plus 1 and the actual values are minus L2 plus L. Students, every quantum number is associated with its previous quantum number. Say for example, if you talk about the S subshell, in the S subshell, what are the values of L? Magnetic quantum number M. What are the values of magnetic quantum number is 0 because it lies from minus L2 plus L. So it will be minus 0 to plus 0, which is 0. And this is one S orbital. So in the S subshell, only one orbital are there. What about P subshell? Students, in the P subshell, where the value of azimuthal quantum number is 1. If the value of azimuthal is 1, value of magnetic will be minus L2 plus L, minus 1, 0 and plus 1, minus 1, 2 plus 1, which includes minus 1, 0 and plus 1. Now how many values are there? How many values are there? 1, 2 and 3. There are 3 values. And what are these values? Listen carefully. There are 3 values. But what are the values? Minus 1, 0 and plus 1. These are the actual value. And what are the number of value? 3 value. Minus 1, 0 and plus 1. These are 3 figures. And each figure represents one orbital, which is pz, py and px. Okay. So there are 3 p orbitals. Now in D subshell, students, in the D subshell, value of azimuthal quantum number is 2. So value of magnetic quantum number will be minus 2, 2, plus 2. What comes in between minus 2 plus 2? Minus 2, minus 1, 0, plus 1 and plus 2. How many values? 1, 2, 3, 4 and 5. So students, there are 5 d orbitals. And these are the name of those orbitals: dxy, dyz, dzx, dx square y square and dz square, that we shall see later. Now for the F subshell, azimuthal quantum number is 3, and if azimuthal quantum number is 3, magnetic quantum number will be, students, minus 3, 2 plus 3, minus 3, 2 plus 3. So it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and of course plus 3. 7 values. And we say their shape is complex. Name is not determined yet. The last quantum number is the spin quantum number, and it is very simple. This spin quantum number represented by the sign S. This quantum number simply represents the direction of spin of electron. this simply determines, this simply represents, that simply denotes the direction of spin. And there are only two possible directions. An electron, it may rotate clockwise or anti-clockwise. We know that electrons always rotates on its own axis. So they can rotate in two directions, either in the clockwise direction or in the anti-clockwise direction. There is not a third value. So interestingly, value of spin quantum number is independent. See, the value of spin quantum number does not depends upon any other previous quantum number. Like magnetic quantum number was dependent upon azimuthal. Azimuthal was dependent upon principal quantum number. But this spin quantum number, students, it is independent quantum number. It has two independent values, plus half and of course minus half. Now please don't ask me that, sir, plus half is clockwise or anti-clockwise, because nobody knows. In the quantum mechanics, there is no such solution in which we say that plus half is clockwise or minus half is anti-clockwise or vice versa. You can suppose whatever you want to suppose. So explanation of this: an orbital can accommodate maximum of 2 electrons, Pauli's rule, and these 2 electrons must have the opposite spin. They cannot be of same spin. So this one is denied, this one is correct, this one is of course denied, they have same spin. And what about this one? Students, this one is also correct. I said they should have opposite spin. I never mentioned that what should be the sign of first electron and what should be the second electron. So according to the quantum numbers, this one and this one are identical. Now we have some certain numericals over the quantum numbers. Let's do some practice for the questions. Using S, P and D and F notation, describe the orbitals when you give the quantum number values as follow. If I say n is equals to 2 and L is equals to 1, students, I say n is equals to 2 means I'm talking about the second shell, and for n is equals to 1, value of azimuthal is 1 means p subshell. So now we are talking about 2p subshell. Similarly here, when you say n is equals to 5 means you are talking about the fifth shell, fifth energy level. And when you say L is 2, remember the value of L and subshell, I told you 0, 1, 2, 3, S, P, D, F. So for N5 and L2, it is 5D. So this represents 5D subshell. Alright. Now another question. How many orbitals are possible in F subshell? Students, for the F subshell, value of L is 3. Azimuthal quantum number is 3. And the value of M, number of orbital, we know that value of M is given by the formula 2L plus 1. So for F, L is 3. So it will be 2 into 3 plus 1, which is 7. So there are 7 orbitals. Suppose in this question, in the same question, suppose I ask you how many electrons we can accommodate in this. So for these 7 orbitals, number of electron that can be accommodated are 7 into 2, which is 14. So we can maximum accommodate 14 electrons in F subshell, not more, not less. Again, one question is there. Write down the values of N and L and also M corresponding to the following orbitals. If I say 2s, when I say 2s, the value of principal quantum number is 2. I am talking about the second shell. As it is S, value of azimuthal will be 0. I told you in the previous slide also, value of S for azimuthal quantum number value is 0 for S. So L is 0. And if L is 0, there is only one possible value of M, which is 0. Minus L to plus L. Minus 0 to plus 0. Yes, but about 3D. If I say 3D means N is equals to 3, third shell. In this third shell, we are saying D means azimuthal quantum number is 2. And if azimuthal is 2, students, there will be 5 possible values of M. Minus 2, minus 1, 0, plus 1 and plus 2. Alright, so there are 5 possible values of magnetic quantum number. So my dear students, this was all about the quantum numbers and the numericals which are associated with the quantum numbers. In the coming classes, I'll tell you about the above principle, nodes and the remaining few topics of this chapter. I hope you enjoyed today's class. Please keep watching and keep on studying. Thank you and good luck to you.